All right, here we are back on page 23, finishing up the note portion before we look at some examples. All right, so the opposite of a sum is essentially a very special case of the distributive property, and it's the idea that we think about, remember, that if there's a negative on the outside of the parentheses, that's like a -1, and that we multiply that -1 by each thing inside the parentheses, giving us the -1 times A plus -1 times B, which is the opposite of A plus the opposite of B. So if you have two things added together and you're taking the opposite of them, it's just going to be the opposite of each of them. Just like we multiply each thing in the parentheses up here by 5, here we're multiplying each thing in the parentheses by -1. Okay, a couple more terms here. So variables and a term itself in the mathematical sense, variables and constants or a combination of the two connected into one unit with multiplication or division. Things that are multiplied together are one term. Things that are divided are one term. Ascending order. When the terms of an expression are put in order from the lowest degree term to the highest degree term. And then the one that is next there is descending order, and that's actually the one that we use most frequently. So you can put a little star by that one. Descending order is the one where we start with the highest degree term and go to the lowest degree term. Now, degree of the term, remember, is going to be the exponent. It may have to be an exponent that has been combined with some other ones, and there'll be a special case of this that we'll look at in the examples. All right, like terms are going to be the terms that have exactly the same variable part. If any. Constants are always like terms because they don't have any variables at all, so they are the same kind of thing as something else that doesn't have variables. And then when we combine like terms, we are going to add the coefficients, but we keep those variables, the exact variables from the terms that we originally had. So in a way, it's like having a common denominator. Once we have the common variable portion, then we just deal with the coefficients and we leave that variable portion alone. Include it in our final answer, but we leave it alone. All right, so take a moment to decide if you think these are like terms or not. So I will do like terms in green, and then not like terms in red, and I will have you guys, I'm going to pause it, and then I will fill in my answers. So pause right now and take a moment to make those decisions based on what you think, and then you can compare to what I have. Okay, so as far as which ones are like terms and which ones are not, this first one is not like terms, this one is like terms, this one is like terms, and this one is not like terms. So 5A and 5B, and sometimes if you say these aloud, you can hear it. So one's A, one's B, right? They're not the same letter even. All right, so here we've got all B's, so we know that those are going to be okay. Here, we've got xy squared, -3xy squared, and 43xy squared. So you can kind of hear that pattern starting, that you've got xy squared for each of the variable portions. And if you read this one, it's xy squared and then x squared y. So those are not the same because even though they have the same letters, we have to have the same letters and the exact powers in both situations. So we would have to change one of those to be able to get them to be like terms. We'd have to work with changing those powers around. All right, so flipping over to page 24. All right, so we are at the top of page 24, and we are going to be talking about some of those terms we were looking at earlier and making some descriptive determinations about the different polynomials that we have here. So a couple things I just want to point out here. Okay, so we're going to have its degree, how many terms it has, its leading coefficient, and also make sure that it is put in descending order. Now, I do recommend putting it in descending order before you decide the other things because it sometimes makes it easier to isolate what the degree and the leading coefficient are. So for this first one here on the left, I am going to rewrite that in descending order so that x squared term has to go first, and then the 7x, and then the 15, the constant there will stay the same in the same spot because it was already in the last place. All right, so its degree is going to be the highest exponent that we see there, and that is going to be 2. The number of terms, it has 3 terms, and that is going to lead us to use trinomial to describe it. And the leading coefficient is what is multiplied by the variable on the highest degree term. So if you have it in descending order, then we know we're going to focus in on the 13x squared. So you look at 13x squared. This has the highest degree of the terms. So the coefficient is just what's multiplied by that x squared portion. So 13 would be that. And then this is in descending order. Like I said, it's probably easiest to do that first because it kind of helps you to narrow in on these. So I am going to pause for a minute and I will fill these other ones in, and then you guys can compare and see how you do. All right, so I realized when I was pausing here that I had forgotten the constant part. So notice that I changed that to number 4, and then descending order is 5. So back to the first example that we had looked at, the constant there, remember, will be negative 15, because the 15 is subtracted, which really means we're adding a negative 15. So negative 15 is our constant there. In the second one, putting it in descending order will be negative, or the opposite of t to the 4th plus 2t. So the degree is 4. That's the highest exponent. There are 2 terms, which makes it a binomial. And then looking at the highest degree term, we look at the coefficient. That'll be negative 1. And then the constant in this case is 0, because there's not one listed, which means that it's, again, it's a hidden one. We don't have to stick 0 on there because it's a constant. It just doesn't happen to be there. But we do need to remember that that would be the constant. 23, so this one has a couple kind of trick questions to it, so I just like to look at it in case it comes up in Alex someplace, so you've seen it. So here the degree will actually be 0, because we are thinking about this as 23 times x to the 0, because that makes this become 1, and it would just be 23 for that value. So it has a degree of 0. All constants have a degree of 0. There's only one term, so it's a monomial. 23, if it doesn't have a variable, there's no coefficient. So there is nothing, so none for coefficient here. And then the constant is 23, because that's the only thing I've got there. So it's a very boring monomial. Degree 0, one term, it's just the constant 23. All right. Let's look at the next couple, and I am going to do some pausing in here again, where I'm going to do one example to kind of give you the idea of what I'm thinking about here in these examples, and then you can take a moment to think about them on your own before you continue the video and see if you're on the right track. All right, so rewriting with the commutative property of addition or multiplication as appropriate. So if I have that and I'm using the commutative property, that means I can write it where I am switching things. Remember, commutative, I'm commuting, so those 2 terms can move. So instead of t plus 2, I could say 2 plus t. All right, I just switch the order. And then for associative property below there, I'm going to go right down there, rewriting that with the associative property. So that is where I'm not going to change the order of the values there. So I'll still have 7 plus 5 plus p. But instead of having the parentheses around the 5 and the p, I'm going to move them so that they are associating, they are grouping the other pair of numbers. So we're going to group the 7 and the 5 this time. So that would be my answer for that one with the associative property. So like I said, I'm going to pause here, and then you guys can compare your answers with mine. Okay, so here on the bottom of page 24, so we are looking at rewriting with the commutative property. So I could switch the order there, -4 times a, and you could put the multiplication symbol there, but I can also write it without it because one is a number and one is a variable. If they are both numbers, I cannot do that. But because there is a variable there, if I just squish them together like this, then it's implied that we multiply them together. Rewriting the opposite of q plus 8 in the other order, so we could have 8 plus the opposite of q, or I could write that as 8 minus q. Both of those mean the same thing. So just know that if your neighbor has the different one, it doesn't mean that one of you is wrong. Those are going to mean the same thing. And then the bottom on the right here, so remember with associative property, we're going to keep it in the same order. So I wrote down my -3, my 2, and my c, but then I want to move the parentheses so they're around the -3 and the 2 now. And I do have to, and this is what my note is about, you have to stick that multiplication symbol in there. We can't just squish -3 and 2 together because they're both numbers. If one of them is a variable, like up above here, or in the one in the commutative property section, then you can just put them together and there's implied multiplication there, but that is not the case with numbers, so you do need to insert that multiplication symbol while you are moving the parentheses. Okay, I'm going to pause and move on to page 25. All right, we are in the top of page 25. So we've looked at the commutative and associative properties, and now we're going to look at the distributive property. So simplify these, rewrite, and then simplify if you can. So first of all, rewriting with the distributive property, remember we're thinking about taking what's on the outside of the parentheses and multiplying that by each thing inside there. And you might not necessarily need to write these in between steps, which is fine. I am going to put them here just so you can see what all I'm thinking about. So I'm doing the 5 multiplied by each thing in there. So then I can get 15 plus 5w would be my simplified answer for that one. And then combining like terms, if we look at that, if check and see if they are exactly the same variable part, then you can add their coefficients. So mentally what I'm thinking is they're both x, so now I can say, well, that's going to be 4 plus 21, because I add the coefficients. And then that's going to give me 25x. Now, remember, this is like x plus x plus x plus x, 4 x's. If I've got 4 x's and 21 x's all together, I'm going to have 25 x's. But the variable part stays the same. We identify it as the same, and we keep it the same. We do not square it. We don't double it. We don't put any powers on it. Nothing like that. Okay, I am going to pause and let you guys look at the rest of these, and then we will compare. All right, so looking back at these, so the distributive property, remember that if you're feeling comfortable with the distributive property, you don't need to put this in between step. Only put it in there if you're having trouble with it. So negative 6k plus negative 12 would be what you simplify to. You could also write it as negative 6k minus 12. And with this next one, I might simplify the like terms in here first, but since we were looking more at the distributive property, I did just multiply the negative 2 by each thing inside the parentheses. So we get negative 2 times negative 10q, negative 2 times negative 12q, and negative 2 times 3. So doing some simplifying, we'll get 20q, because those negative signs will cancel out, positive 24q, also canceling out there, and then a negative 6. So either 44q minus 6 or 44q plus the opposite of 6, or plus negative 6. In the next couple with the like terms, just double checking. Are those exactly the same variable part? They are. So I just